Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Ahmad Ismail Yusuf. Today I will present my research paper topic about analysis on the surface roughness and microstructures of the laser sintering part affected by orange peel texture. The purpose of the research is to investigate the effect of orange peel surface texture on the part's surface finish. The research analyzed the surface and microstructure of the orange peel surface texture on the laser sintered parts. The orange peel surface was identified to undergo surface roughness measurement and microstructure analysis. Then a classification of the degree of seriousness of the orange peel texture was proposed based on the surface roughness measurement result. Finally, it was found that parts made from recycled powder have a poorer surface texture and contain a large portion of unsintered powder particles. Based on the findings, a better understanding of powder recycling is defined, especially in the scope of surface roughness and microstructure. This result will allow researchers to make improvements in the laser sintering process. Powder material used in laser sintering and their applications. Laser sintering or LS is one of the most versatile rapid prototyping or RP process currently available. One of the main advantages of employing this technology is that the non-sintered powder can be recycled and reused for another fabrication. However, the fabricated part could be affected by a rough and acceptable surface texture. As a result, the parts may have to be scrapped and the build has to be repeated with a higher ratio of new material. This causes delays, customer disappointment, and additional expense. Sometimes, this could be avoided by adding plenty of new material. However, this will also raise the production cost due to the high proportion of material cost within the total of the laser sintering manufactured. Laser sintering is one of the most versatile rapid prototyping process currently available. Prior to this study, the aging of PA12 powder and more efficient recycling in the laser sintering process had not been thoroughly investigated. Most previous research was carried out using PA12 as the focus for the study of thermal, mechanical, and chemical properties that affect the surface of finish. The related research reviewed in this related to the GONET study how the mechanical and thermal properties of laser sintering part made from durable material, which is the trade name of PA12, power produced by 3D system. It was affected by the number of peels or the number of times the powder was used in laser sintering station 2000. GONET has used the plastometer, which is commonly used tool in injection molding industry, was adjusted to measure the flowability of the used Duraform powder. One of the conclusions was that after approximately 7 to 8 builds, the properties of the processed material were so badly deteriorated that it should be fully discarded. However, the effect of orange peel texture, which affects the surface of sintered part, was not investigated. Experimental procedure, design and fabrication of bench parts. To achieve the objective, the experiment was done on a test subject, which was a laser sintering benchmark part produced under the default setting of the 3D system since the station 2500 H2 laser sintering machine. The benchmark part will be tested to obtain the properties of the surface roughness and microstructures of orange and orange peel surface texture. The benchmark was specifically designed so that the properties mentioned above could be tested. design and fabrication of bench parts. To achieve the objective, the experiment was done on a test subject, which was an laser sintering benchmark part produced under the default setting. The model of the sintering bench passed the test using pro-edge as shown in the figure below. The size of the benchmark is 110 by 110 by 48 millimeter high. The file was then converted to STL format before it was transferred to laser sintering machine. The benchmark will be tested to obtain the properties of surface roughness and microstructure of an orange peel. Result and discussion. Classification: the degree of seriousness orange peel texture by roughness. The data of surface measurement by Mitutoyo Surftest SV500 in y-axis of 24 samples located at different positions of the part yielded could be classified into three major groups. It is the orange peel sphericity, where goods exhibit no orange peel texture. Second, mild, shows signs of orange peel surface texture appearance, and orange peel which exhibits a clear orange peel surface texture. Microstructure of orange peel surface texture. The result of the microstructure experiment on the orange peel sample justifies the result yielded by the surface roughness experiment obtained previously. The surface texture that was severely affected by orange peel has larger holes and more porosity in its structure because of the unsintered powder. The characteristics of the microstructure were the same as previous research done on the material duroform. This phenomena was explained by figures as shown below. It can be seen that the external surface of the good and orange peel parts which clearly differentiate the finish. It was found that the higher the melt flow rate used in laser sintering process, the lower melting viscosity. This results in the polymer particles within the layers fusing easily, which leads to a smooth surface. By contrast, employing the twice-used powder with lower melt flow rate, agglomerates of melted particles can be observed, which are in the direction of the laser scanning lines. Between the sintered lines, extended holes and cavities can be observed. The external microstructure of benchmark on the XY plane can be seen, as shown below. These results suggest that the use of refresh powder results in formation of microstructures with a highly dense morphography. In contrast, the cross-sectional structure of an orange peel texture exhibits a very inhomogeneous structure after laser sintering. It is observed that cavities have different shapes and sizes. The average cavity size is approximately 100 micron to 200 micron. The cross-sectional structure of an orange peel texture exhibits a very inhomogeneous with different shapes and size, and it's very what we call void when employing twice-used powder as little as 100 micron to 160 micron, and it may be clearly seen that the average cavity size is approximately 100 micron to 200 micron. This classification can be used as a tool to determine the degree of orange peel severity of the LS part. However, further research was demanded to obtain a more definite and reliable tool for determining the degree of orange peel severity by considering other factors that may affect the quality of LS part or laser sintering part. Conclusion: the orange peel phenomena is one of the main constraints in the LS process or laser sintering process, as it causes unacceptable laser sintering part surface quality. It happens when deteriorated PA12 powder is employed in the laser sintering process. The appearance of orange peel in laser sintering part surface structure has contributed a rough surface and weak structure as it has become more porous due to the existence of holes and untreated powder particles. The investigation has succeeded in classifying the degree of seriousness of orange peel surface fracture into three major groups based on the result of the roughness measurement of part surface texture. Thank you very much.